Great. Okay, so we're going to kick off next with Adam Rackis. He is going to do an alternative or an alternate approach to GraphQL caching. So I am going to hand over control to him, and he will go ahead and get started.
Hello, and thank you. Let me see if I can share my screen. Are my slides visible? All right, thank you. All right, GraphQL caching, a different approach. This is going to be a little more down in the weeds than the last talk. This is going to be more for web developers, especially folks who have used GraphQL at least a little bit. It's going to be a little bit React-centric, but if you are not into React at all, that's totally fine. There's still a lot in this talk for you. This is me. I am a software engineer at Riot. There's my Twitter handle, and that's where I am at GitHub. And I mentioned the latter because you can find these slides in the micro-Graphql-react repo. And if you look at the README on that project, you can actually run these slides. There's a link to the slideshow already running. So if you want to see anything in here, you can just hit up the README for the GraphQL client I'm about to show you towards the end of this talk. Okay, so I just want to preface this talk by saying that every GraphQL client has trade-offs. The point of this talk will never, ever be about identifying which client is better than the others. That's just a meaningless thing to even ask. They're not better, they're just different. And I'm going to talk about some of the trade-offs that other clients have made that have frustrated me in the past and sort of motivated me to build the client that I'm going to show you towards the end. Just a little bit of GraphQL 101 that's going to help us out here in case anyone didn't know. So this is what a GraphQL query might look like, the simplest query imaginable, and it's going to send us back some data. There is a cool little thing built into GraphQL where you can add this underscore type name to it, and you don't have to implement that in your schema at all. It's just built in, and when you do that, when you add that type name in, your results from the server are going to now include type information in your result sets. And that is how, and there it is. So that's the type of the actual query packet. And then each individual object in your result sets are going to have that type name identifying the type of it, book or book query result sets, whatever it's called. And that's how GraphQL clients implement caching. If you've used GraphQL clients like Urql or Apollo, you don't usually pass your query right to the query hook. You usually have to attach some sort of tag template literal to it. And what that does is, among other things, it injects that type name for you so that your results are going to all include type information of the data that you're getting back. And so the GraphQL clients do that. They keep track of your queries. And as they're storing the data, they're gonna cache it based on those types. And when you run mutations, it's gonna also inject that type name for when you get the results of your mutations back. And so that's how these GraphQL clients are able to synchronize the data and the mutations and update existing data when you run mutations. But there's a catch. Caching's hard. I don't know if anyone has ever noticed this or pointed it out or made a joke about it, but caching is a tricky thing to get right. The previous talker even had a bullet on this. Yes, caching's hard and it can go bad quickly. So now I want to go through the two main sort of caching stories in the GraphQL ecosystem today. I'm going to start with normalized caching, and then I'm going to go to a GraphQL client called Urql and talk about how both of those do caching and some of the trade-offs that they make. So let's talk about normalized caching first. These bullets are going to be a little bit high level, but there's going to be lots of examples to follow. So with normalized caching, every item in whatever result sets you're getting back are going to get stored by ID and type conceptually. And then the result sets themselves, they don't actually store the results. They just store a list of IDs contained in that result set. And then when you mutate an item, it just updates it in the cache and everything gets updated. I know that's probably hard to follow, but here's some examples for you. Let's look at actual code. So let's take that query that I showed you before. let's say that query returns data that look like this. And I'm leaving off the underscore type name everywhere because I want to keep these slides. I don't want the slides to get overstuffed with too much stuff. Book number 2 has a typo in it. That's intentional. So we run this query. And if we get these data back from that query, a normalized caching solution might do something that looks kind of like this. It might have some sort of query cache, and it's going to take the query that we just ran, and it's going to somehow sort of scrunch all of those variables and the query name and all that into some identifier. It's going to be really long. I'm just calling it X, and then it's going to stringify your variables, and then it needs to store the results that you got back. It's not going to store the actual book objects. It'll just store the IDs. So where are those book objects stored? In some sort of separate cache. So if you've ever used Redux before, some of this is going to look kind of familiar. When you use Redux, you also have to normalize your data. And there's some really cool things that happen when you normalize your data. So this is what our object cache is looking like right now. So any part of your UI that's running this query right now, the cache is going to say, okay, my results have books 1, 2, and 3. What is that? Well, I'll look up books 1, 2, and 3 from the appropriate cache. And let's say we run a different query. The last query said Civil War. This one just says the word last. And let's say we get these data back. Book number 2 comes back again, and we've got 2 other books that both have the word last in it. So our query cache now has 2 entries in it. The first one, we looked for Civil War, and we got books 1, 2, and 3. And then we looked for the word last, and we got books 2, 4, and 5. And our object cache is getting a little more crowded, but that's okay. And so here's where the payoff is for doing all this work. So let's say we want to update book number 2. If you noticed, we spelled chance wrong. That was intentional. Let's go and fix that now. If we run a mutation and we say update book number 2, and we give it some changes to apply, and then the mutation is going to send back the data that were changed. I am including the type name here. So our whatever GraphQL client we're using, Apollo or whatever, is going to say that, hey, a book was changed, ID of 2, and here are the changes. And so our client can just go into the object cache and update the appropriate entry. And remember, our query caches, we're only storing sort of pointers to the actual entries in the object cache. And so what that means is, once we update book number 2, our Apollo cache or whatever we're using, it's just going to sort of broadcast that something has changed. And any piece of our UI that was running either of those queries will just see book number 2 update automatically for free. And that's really, really cool. When you first start using GraphQL and you use a client like that and you see things change in real time just on the client without having to fire a new network request, it's a real nice sort of hit of dopamine. It's a good feeling and it makes you really excited about GraphQL. But things aren't quite so perfect. Things can go wrong really quickly. Let's abandon the book example and let's go back to the tried and true sort of to-do list. We've all seen the to-do example bandied about a million times in web dev. Let's say we're building a to-do list. And let's say we run a query and we say, hey, I want to see all of the to-dos that are assigned to Adam. And let's say we get some data back. And we have task number 1 and task number 2, Adam's task 1, Adam's task 2. And let's say we run a mutation and we say, hey, I want to update task number 2. That one actually should be assigned to Bob and not Adam. And so the normalized cache is going to go in and update task number 2. I'm not going to walk through every single step before. The query cache exists like before, but we're going to update our object cache. Task number 2 is going to update, and now it's Bob's task, and the assigned to is Bob. And our query cache is unchanged, right? This was the query that we ran, task assigned to Adam, and it still contains the same 2 pointers. They're not really pointers, it's just sort of a metaphor. We can think of them as pointers to the entries in our object cache. But But this is bad, right? Because task number 2 is no longer assigned to Adam, it was assigned to Bob. It should have been ejected from the result set, not updated. Of course, GraphQL clients that use normalized caching, they have escape hatches to deal with this. In my experience, they are not easy to work with. They're hard to get right. Don't take my word for it. Don't walk away from this talk saying that Apollo is too hard to use. I'm not saying that at all. Just sort of, this is a problem with normalized caching that you have to be aware of. Anytime you're filtering data and then editing that data based on the filter conditions, this is something that you're going to run into and you're going to have to manage it. And so just sort of be aware of that when you're considering GraphQL clients. Does that mean normalized caching is bad? No, of course not. The clients do have escape hatches. Check them out, see if they suit your application's needs, because that's really all that matters. You might be building a web application where this isn't even a concern for you, in which case Apollo is going to be amazing, and I urge you to use it. Let's take a look at a different caching approach. There is a GraphQL client called Urql. It was made by this magnificent human being named Ken Wheeler, personal friend of mine. That's him in New York. Urql takes a different approach to caching. It's not normalized caching. What Urql does is for each query that you run, it keeps track of which types of data the query contains. And when a mutation modifies data of that type, no matter what, the entire result set is invalidated. The entire cache of that type is cleared. So let's take a quick look at what that means in practice. So let's go back to our task query. Let's say we look up tasks that are assigned to Adam. Let's say we get some data back, like before. And so with Urql, conceptually, we'd have something that looks like this. We'd have a query entry for the query we just ran, but instead of just holding a list of quote unquote pointers, we're actually storing the actual results of that query. ID number 1, here's the description, here's who it's assigned to, etc. And now when we run our mutation, we're going to get back a mutation result that says that a task was modified. And so Urql is going to say, okay, tasks have been modified. So it's time to clear out the tasks cache, because I cannot rely on any cache data. The filters may have been invalidated. I'm just wiping everything clean. And now the next time you need that data, it will be requested from the network. Cache is empty. And if I'm sure you're wondering what that means for the data you're already looking at, those results will stay on the screen and your user can keep looking at them. And then in the background, Urql is going to refresh that data from the server. So awesome, right? This is perfect. We're done, right? That's the end of the talk. This is perfect. Use this. We keep track of the types that each query returns. Unfortunately, even this isn't fail-safe. You can have a situation like this. You can run a query, and what if I've already done all my tasks and the list is empty? There is nothing to attach type name to, and so Urql doesn't know that this query relates to the data type of task. So if you somewhere else in your UI create a task and assign it to me, or if I create a task and assign it to me and I save it, Urql is not going to know that this query needs to be updated because it doesn't know that it contains tasks because the result set's empty. This is really easy to work around. Urql has an option. You can just tell it when you run this query that it contains tasks. This is no big deal at all. It's easy to work around. So Urql is correct by default, in my opinion, and my opinion only. I prefer Urql's approach to normalized caching. There's too much that can go wrong with normalized caching. And if you recall, I told you normalized caching, the escape hatches were hard to work with. If you think about how normalized caching works, you've got sort of separate caches for your objects, separate caches for your queries. Just thinking about it, it's probably going to be hard to interact with that at that low level. It's not surprising, in my opinion, that those sort of escape hatches are difficult to work with. And so Urql sort of sidesteps that, and it just sort of punts, and it says, when you update data that I'm managing in this query, I'm just going to wipe the cache clean, and now we're going to start from scratch, and I'm going to request data as needed from the server. That said, it would be nice if we had more flexible cache update mechanisms with Urql. So wiping the cache and reloading the data is cool, and that works. But sometimes you can do the sort of Apollo-like updates that a normalized cache gives you for free. Sometimes you get updates back from the client, and it would be cool if you could tell your GraphQL client, hey, we don't need to clear the cache, just update the results in place, and that's good enough. I'm verifying to you that those updates that you just made, they are not related to the values by which you're filtering. Maybe you have an administrative screen and you've just got a whole list of task types or task statuses, pending, to do, finished, done. You're not ever going to filter those task status types. There's just one list of them. If you update them, then just update them in the client on the front end. We don't need to update, we don't need to re-request the data from the server. It would be nice if we could do both. And that's why I built my own GraphQL client, because I wanted those sort of options. I wanted something that let me do either. So the results are cached by query, just like Urql does. There is no normalized caching. That is ridiculously hard to get right. So I don't even try, just like Urql doesn't even try. But the cache updates are completely flexible. So how is that possible? Well, you do everything yourself. But it's not as bad as it seems. And this is the part of the talk where React starts to come in. But any modern front-end framework, Svelte or Vue, they all are going to have something along the same lines as hooks. So this can apply to any front-end framework. The front-end, the client that I built is built specifically for React, but the concepts I'm talking about, you could, if you wanted to, build them for any JavaScript framework. All right, let's take a look. Here's a few terms that I made up. I don't know if these concepts have canonical names already. If they do, I apologize. But hard reset is what Urql does, as far as I'm concerned. I gave it that name. I don't know if it already had a name, but if I say that I want to hard reset my cache, I'm going to clear my cache out, and I am going to reload whatever queries are already on the screen. If I say that I want a soft reset, that means I'm going to clear my cache, but I'm not going to re-request the current results. I'm just going to update them optionally. I'm going to say, all right, the results you're currently looking at, I'm just going to update them on the screen, but the cache is cleared. And if you come back to those results, I am going to make a fresh request to the server. So from a UX perspective, maybe you're looking at a list of tasks, and maybe you do reassign task number 2 from Adam to someone else. I'm going to leave it on the screen for you. So it's technically incorrect, but maybe you decide that when you reassign a certain task, you'll just leave it on the screen with the new assigned to, rather than have it vanish off the screen immediately. But anytime you come back to that query, you will get fresh data from the server. And of course, this client will let you just update the raw query cache if you want. All right, let's take a look at some code. This is a React component. Let's pretend that we have some sort of books component. It's going to request some data. And then starting on line 13, it's going to pull the book data out and then render some HTML starting on line 15. It's JSX, but pretty similar. And if anyone's noticing the crazy syntax on line 13, that's the sort of conditional operator that was just added to JavaScript a few months ago. And the question mark is sort of a null coalescing operator that was also recently added. Okay, but we're not concerned about those things. So here's how my client works. It's got a use query hook, just like any other client is going to have. You give it the query on line 3. You're going to give it some variables on line 4. But here's sort of the secret sauce. Here's where you specify what you want to happen when you mutate some data. You say on line 6, hey, whenever any mutation happens, I'm going to give you a regular expression based on the result sets that come back from the mutation. And then you give it a callback. And the client will call your callback, and it will inject some functions that you can call. It'll give you a hard reset function that does what I said. It'll give you a soft reset function. It'll give you a reference to your current results. And it will give you some other things. There's only so many columns on the screen here. It'll give you access to your to the entire cache if you want it. It'll give you a refresh method if you want to just refresh the current view, and then you do whatever you want. But we don't want to, if you're thinking, hey, that is a ridiculous amount of bloat and I can't possibly use this to write application code, it'll be ridiculous. I'd rather deal with normalized caching. Yeah, I hear you. But hooks can sort of clean a whole lot of that boilerplate up. And if it wasn't for React hooks, this project would be a lot less feasible, I think. So let's say let's take a closer look at that books component. And let's say we want to just hard reset. Anytime you update or delete or insert any sort of book data, we just want a hard reset. Okay, so I am going to give my on mutation here. Oh, and right now I'm giving it a single object. If you want to do different things based on inserts and updates or deletes, you can also pass an array of objects. Either one is fine. But if there's just one thing, you can just pass an object. So on any update, I'm going to give it my callback on line 8, and I'm just going to run the hard reset. And let's say we have some other data, some other component that uses a different kind of data. Maybe there's a subjects component. It's going to be pretty similar, right? So similar, in fact, that the only thing that's different other than the name of the query variable, these are basically identical except for the type name that we're injecting into the regular expression. What if we just sort of parameterized this hook based on that type? And hooks makes that really easy. We can just make a hard reset hook that takes in the type and also the rest of the variables that our query hook wants. And it will, as I said, inject that type into the regular expression for us and then call hard reset. And so your application code looks a lot better than it did before. You call that hook just like you do the regular query hook. You just pass it the name of the type. But even that's really ugly and hokey, and it's not very type safe, and it's just annoying. You don't want to be passing that string in everywhere. But more hooks, right? Why not just partially apply that type name? Why not just in some sort of centralized utility file, you can define the hooks that you need for the various types that you have. There's hopefully not going to be too terribly many of those types. Why don't we just make a hook specifically for books or subjects and partially apply those types up here? And now we can use it and we don't have to pass that string to represent the types. And so that's cool. I want to pump the brakes a little bit. We haven't really done much of anything. Hard resetting isn't complicated, and it's what Urql already does out of the box for free. So all we've done so far is just build a more complicated version of Urql. The value added is when you want to start doing some of the other use cases. So again, the value added is, what if you don't want to just hard reset all the time? What if you want to do other things? If you want the flexibility to do other kinds of updates when mutations come in. And so let's take a quick look at one of those. Let's look at soft reset. And the code's going to be a little scary at first. So here's what a soft reset query might look like. We take in the type like before. We've got our regular expression just like before, but the callback's a little more complicated now. So we need to get the updated records. So you may have updated a single item, or you may have done a bulk update, I'm assuming. This is for my GraphQL schema. You can update one or update multiple objects. So get the objects that were updated, however many there were. And now for each of them, pull them out of the current results and update them. And yes, I know this is an n squared. If that's, you're probably not updating thousands of objects. And if you are, you can find a cleverer solution than this, but this is probably going to be good enough. And then once you update your current results, you can call soft reset. And that's going to clear your cache out, but it will leave your current results alone. So this is a use case I found myself wanting when I update an item. I wanted them to just update on the screen and stay there, but get ejected from cache. So if I go somewhere else and then I come back, I wanted fresh data, but from a UX perspective, for some use cases I came across, I just wanted the stale data to stay there. I wanted the updated data to stay on the screen, even if it wouldn't necessarily apply to the current search results. I felt that was better for me than having it immediately vanish off the screen. So some more perspective. Yes, this is more work. I just did updates. If you look at line 5, all I'm messing with are updates. You probably want to do something for inserts. You probably want to do something for deletes. It's actually going to be a little more complicated than this, but it's doable. And this project aims to give you that option. Again, I made this project because I wasn't happy with the cache update options that were available, which is why I put this together. And I found that React hooks, it allowed me to sort of write this logic the way that my own application needed one time, and then I was done. I could just use it. So the soft reset hook, yours might look a little different if you need it, but you only have to write it once. And again, you can also just do raw cache updates if you want. If you can go even further. If you don't have any sort of filtering, or you're convinced that you're not ever going to mutate things, you're not ever going to mutate data by which you're filtering, you can just go in and update all your cached results. I give you similar update mechanisms to do just that. All right, so you want to pick the right GraphQL client for you. None are better than the others. They're just different, and they make different trade-offs. Think about what your app needs, because that's all that matters, is whatever your use cases are for your app. Think about the problems that each of these caching approaches use, how they solve them, and think about the problems that some of these cache approaches run into, and ask if your app even applies to that. Ask if your app is going to suffer from those problems, because it may not. If Urql's cache update behavior is good enough for your app, absolutely use it. If you are happy just hard resetting everywhere, then Urql is an outstanding client to use. I think it was the Red Bull I just pounded, but I think I'm a little bit fast on time. But I would love to answer any questions if folks have them. I am not an avid Zoom user, so I may need some help screening the questions.
Yeah, we got